Okay. Okay. As I mentioned earlier, okay, for depot, in the depot is what we have for them to prior start laying cables and all that. Yeah. And at the track, once they have laid cable and everything, is they will put IDs at the track, which we call as trackside markers or sign at the track. Okay, all this sign is for technical reasons, and also for the drivers, and also for the maintenance staff to know what we have on the track. So every track laid is numbered. This is for future maintenance purpose also, and also to identify in case anything happens. Okay, it's called we call it as chainage. Okay, chainage is each ballast or the wooden which is laid. Those days name is chainage. Now we just call section. Okay, or segment of certain tracks. It's all numbered at the track site. Yeah. Okay. Once we have all that, you know why this marker? Okay, this marker is, you have the track already. Okay, you have the track, you want to lay cables and all that. Now from the depot you are going to take out and go to other direction. So you need to have an equipment or transport mode of thing to bring all these stuffs, this track, the equipments and all that. Okay, that is where you will have track vehicles. Okay, as you can see, these track vehicles.
Okay.
These track vehicles, you can see from there, here. Okay, it has got wagon where it carries all that. Even track they put on top of that, they will go, okay, and bring down. Okay, and this will carry staffs, and that is called binatang dua alam. Okay, why binatang dua alam? Okay, because you can use it in the road, on the road, and also on the track. It has got a wheel, so we call it binatang dua alam or unimog. It's also called as unimog or MPV, multi-purpose vehicle. Okay. Okay, this is all the types of track vehicles which we have, which is used to lay the cable, to prepare whatever necessary engineering equipments before the start of the railway. Okay, so these are the track vehicles which will move first and do. Normal people, we don't know. Okay, what we know is the government will announce. You see in the media saying that, okay, we have trains, it will going to be it will be in operation on this date, so please come, 1 week free ride. Okay, that is what we know. Okay, we don't know all this. Okay, this is before, backstage lah. Okay, before we start the show. Okay, this is all will happen. Yeah. Yeah, rolling stock. Okay, just now you had a question. What was that?
I was asking, what is that for?
Which one?
The first one.
That's called trolley for them to travel, just like tuk-tuk lah. Okay, small one. Okay, and another thing is all the small, it is not detected in the control center. Okay, it is not signaling compatible.
But we still have this one, right?
Yeah, we have to have this. All these now we still have it. We use it for maintenance purpose. That means after operation hours, when the last revenue train, all the train go back to the depot, we need to maintain the track, do maintenance of the signaling, okay, do maintenance of the viaduct. So all these track vehicles will go in. Okay, if you are staying alongside of the MRT or LRT, okay, it will be a big nuisance when you see all the, because most of it is all diesel. It's not electric. We have some battery also lah. Okay. Most of it is diesel, and normally it's very noisy when they work, when they do the maintenance work, when they travel along the track. Okay. Track vehicles, and then comes our big boss lah, rolling stock. Okay, why it's called rolling stock? It's where it keeps a stock of the rolling. The train is called as rolling stocks. Okay, so in this picture you can see various kind of trains, whatever trains we have. Okay, nowadays for KTM it's called EMU. The set is called EMU. Okay, EMU. It means electrical multiple unit. Previously, before all this cabling and all that, it was called DMU, rail car. I don't know whether you were born at that time. Okay? We used to have a similar, like what we have with the KTM commuter. It's called DMU, diesel multiple unit. It looks the same, but it operates using diesel engine. Okay. Now what you see in KTM and all that, it's called EMU, electrical multiple unit. Okay. What else type of name, train names in EMU, DMU, some more?
The one in Sabah before, they have one train, right?
Yeah, that is DMU, diesel multiple unit. What is LRT? Sikit-sikit cakap, saya mau naik LRT lah, saya mau naik MRT lah. So what is that?
Line rapid transit. Line. No, RT is rapid transit.
LRT, It all has got a definition by itself. LRT. This is light. This is rail transit. Okay. Maximum 1,200 to 1,005 packs per train.
Oh wow.
Okay. Then we have MRT. Okay. The only difference is this is light and this is mass. Okay. Mass rapid transit, which can carry up to 2,000 passengers per trip.
So like when peak hours, when we feel that the train is full, there are really like that many people, is it?
Yes.
Inside? Oh wow.
Okay, 1,200, 1,005, it can go up to 1,008. We call it as crush load, sardine, but we don't practice that already here due to religion purpose. We don't practice crush load. In Japan, it's packed. They have a person who is called, I forgot the name of it. His work is to push people to go inside. That means passengers will come and wait, right? So these people, they are hired just to stand at the platform and push the customers to go inside. Imagine how packed it is. Okay? So MRT carries more passengers. That is called, why it's called MRT. It's bigger. LRT is a bit smaller. Yeah. And yet, if you go to Bukit Bintang, you can see MRT at peak hours. It will stop. You see passengers going in, and still we have passengers standing outside.
Yes.
So imagine how crowded it is. Okay, and imagine if any emergency or what. It's not easy, when you have packed load. Let's say that train has got an aircon problem. For the technician, he cannot go inside and attend that. Even if he just wants to reset a breaker because the train is packed. They cannot walk inside or go to that portion of that part where they want to reset.
So what happens in that kind of instances?
It would take time. So that
people
comes
feel
back to
suffocated
efficiency. Yeah.
So like that day they had one incident where the LRT Klana line, the door opened while traveling, right?
That is system fault. That normally whatever we have, it's called fail safe. It doesn't occur like that. That one was human error, sorry. Because that technician isolated the door, but he didn't lock the door. They have a procedure. It has got a pin like this, you know. If there's a problem with the door, okay, they isolate to bypass so that it doesn't show in the alarm system. Like our car, okay, like our car. When you are driving, you open the door. What will happen? Or you take out your seatbelt. Alarm. Okay, same for trains. It has got the safety system. Okay, the safety system is it should not travel when the door is open.
So he bypasses.
In case the door opens for any other reason, people break or whatever, emergency brake will apply automatically. It will stop because it's not safe for the passengers if the train is traveling with the door open. People can fly away. Okay, so when we isolate a door where we bypass the system so that it doesn't disrupt the whole train, they have to lock it manually. Okay, lock it or put a tape, barricade it. Okay. Okay, this one, my experience when we were doing our Commonwealth, the train was, the platform was so packed, okay, and the crowd was so massive. When the train came in, they were pushing, the door came out from the rail. Okay, the door came out from the rail. Okay, one car, the door came out. So we cannot, actually the procedure is, I cannot take passenger and go.
Correct.
But at that point of time, it's like so packed, you know. What to do? What we did, we called, assigned two PB to go there, barricade, put the barricade tape at that car, and let the passenger go in and run the train with door open. We override the safety.
Scary.
Yeah, no choice. And then the next station, we disembark the passengers. We disembark. You need to clear, the one way to clear the passenger at a packed platform is by using an empty train. Imagine, I can clear 1,500 passengers per trip. Okay? So let's say I don't cover that. I go there, I don't take the passengers, I just move. What will happen? It will be much more crowded. Okay? So that is what will happen now.
So like in India, they all hanging outside.
KTM.
No, in India, railway.
Okay. Another thing is, theirs are manual. The door is not integrated with that safety or any features. Okay, it has got nothing to do. Just like our KTM old trains, you can open the door, you can wait outside, look. Get people even sing song. Nowadays, even I saw one TikTok. He was doing selfie in India. Train door open. The train door was open. He was doing selfie. You know, these cables, they always have this pole and all that along the canal. Okay? So it still happens there, but they are so used to it there. And you have to understand now they have sophisticated system. Initially, even KTM had that. We don't have that. We call it open system. Open system is you can join the train wherever from the track or where you walk somewhere and just go inside the train. Okay, now it's called closed system. Closed system is you enter at a designated place and you exit at through the gate. It's called closed. Okay, closed system. It means you have to buy a ticket or token to enter the train. Okay, where open system you can go from where mana-mana just lompat and then masuk the train lah. Yeah. So that is where last time you might have watched MJ movie. His leg will get trapped in the the switch, the switch, and then he can come out. Yeah, that thing all doesn't happen at all. Once it's locked, it's locked. You cannot go and take out your leg and all that. You cannot go and pull the thing. It doesn't happen at all.
So there's a manual
lever. We were given a wrong idea. Yeah, manual lever, yes.
So in the movie they push the lever, then the train open. So the one
yes.
actually for diverting the train.
That is for manual switches. We don't have that anymore. We only have that inside the depot or at the siding and all that. Not at the main line. We don't have that. It's all remotely operated or motorized.
Okay.
But I don't know how they do that lah. Even in our latest Tamil movie also, I saw one movie, motorized switch, you can yet escape.
It's a movie.
It's a movie. Okay, okay. There are two types of trains. Nowadays, we have automatic trains. Automatic trains is driverless trains. They don't have drivers. So when they don't have drivers, do you think they need signal? This kind of signals?
No need, right?
No need. Because who's going to
Yeah,
see?
who's going to see?
Okay. So nowadays systems we don't have this kind of signals. Only at the depot. Because at depot normally even automatic trains are driven manually. Okay. At normal at the section and all you cannot see all the signal lights and all that.
So no drivers at all.
No drivers.
Nobody inside.
Yes. Supposedly it's designed to be with nobody inside. Japan, Singapore, they are so reliable, the train is so good, they don't have people. Here, we still have people. One is because of the system, another thing is because of the mindset. I think now, like Klana Jaya, you go to the train, you take the train, you see in front there's nobody there. People have accepted that, 20 years ago when they first started off, it was like they were like paranoid, when they see there's no driver and all that, they start shouting and calling the security guard and asking how come this train is running without the operator and all that. But now, yeah, people have accepted that trains can travel without passengers, without drivers. Yeah? In MRT we still have drivers, even LRT we have drivers. Like LRT trains, LRT Ampang line, they are using drivers. They have two modes. They can be automatic, they can be drivers. Okay? Even our trains, okay, but our trains is more towards the whole system is automatic without drivers. But we still have one person in the train in case of emergency or failures. But in Ampang line, we need one person to operate the door. That means each time the train comes to the station, there's one person to operate the door. And you know why in Ampang we have that? Initially, when Ampang LRT started, was fully manual. Okay, so they had around 150 drivers employed. And then when they had another new system in where they want to put all the 150 drivers, more than 200 drivers. Maybe.
So now what happened to all of them?
So that is why they modified the design so that they will have one operator to operate the door. Same goes in Singapore also.
So those drivers became they
Door
started
operators.
to operate
But
doors.
of course they can drive the train and they have to be competent They have to know how to drive the train manually and all that one. But actually that the train can travel without anybody, unattended. But they didn't do like that. They just did a bit of modification so that they can still have all this, still have job available for the drivers and all, the previous drivers and all that.
So after this, there is no festival.
In future, I think, you see, once we buy a train, we will use that for nearly 20 years or 10 years, minimum 10 years now, because it's not cheaper. So, of course, they will use, unless they plan to have another job task for these drivers, they assign them, they buy a brand new train without drivers, and then push them off.
So KTM drivers, they can.
KTM is manual, totally manual.
If they want to drive the LRT or MRT, cannot. They are not competent.
They have to go for different training.
Oh, okay.
Because the train, each train, even LRT in Klanajaya, LRT in Ampang or MRT, MRT line 1, line 2, inside is different. So they need to go for courses. Okay, MRT has got no driver actually. I mean, it's supposed to be a fully automated train which is controlled by the control center. Okay, controllers will assign the route and everything. That the drivers will come in when we need them to, when we have failures and all that. Okay. Okay, these are the types of train you can see. Okay, this is broad gauge. The gauge is bigger, very large, you know.
Yeah.
I think 2 meters, I think. So imagine how stable the train is, and it can really go until 300 kilometers plus. Okay, and this one is using cable. So cables train are not that speed. Okay. And now the latest one is maglev. Maglev. Okay, maglev is floating train. Okay, what happens is that one is a AO. Yeah.
Magnetic aviation.
Okay. So this is the track, and this is the wheel, right?
No. And the pole magnet.
Yeah. Okay. This is the wheel. Okay. Okay. Don't have jangan muta kuning ya. Okay. This is the wheel. Okay. Okay. Something like this. What happened in maglev is this train will travel on the track for a certain amount of speed, and after that it will go up. Okay, it will go up. This wheel will go up due to the magnetic field of it. Okay, magnetic, and once it goes up, the passengers will not feel anything. It's flying, okay, because it's not touching anything. It's flying. Okay. And when I was in China, they demonstrated to just showed me you know, a cup of this one. It's not shaking or anything.
Oh.
It doesn't shake anything. Nothing, you know, you don't feel anything. No sound, nothing. And when you see the speedometer, 500 kilometers.
Wow.
Okay, it's like flying. It's actually flying. Okay. That's the advance of it. And then the design, why another reason is the suspension system. Okay, this is the saloon inside where we are sitting. The suspension is, it has like this suspension. That means spring here, spring here, spring here, spring here, and they put the coach inside. Sorry, like this. That means, okay, only the outer body moves. Inside, it's stable. That means it's like this. Okay, the outside is moving, inside is always stable because of the
Everywhere suspension.
suspension. So you won't feel anything. Even plane, we feel, right? So much of things.
Yeah.
This one you won't feel anything. Lagi canggih. Tapi tiket banyak mahal.
Oh,
Expensive.
but at least must try once, huh?
Yeah. And the best part is from one station from one stop to another stop, like we took like one terminal to another terminal. It's like I don't remember how many kilometers is that lah. When they said okay you have reached here, it's like so far away, you know, so far away. Within 2-3 hours we are there already. Yeah. It's like 2,000 kilometers.
Oh, wow.
Like 1 or 2 hours, you are like 2,000 kilometers away.
How nice, huh?
Changi. And they are like very comfort inside.
That was
Comfort, Magla.
China.
China.
From here to Kelantan, why they don't want to be like that? Zip like that.
I think the one I answered you just now.
Yeah, you answered already, but it would be nice.
They are doing now. The
Yeah.
refurbishment, they are starting.
The Kuantan one,
From
right?
Gemas, yeah, Kuantan. You saw the route. It's a nice route.
Looking forward to.
Kuantan, that means you can go to Perhentian, you can take the train. The thing is, from here for you to go to the East Coast train, you need to go to Gemas and from there transit.
Oh, from here we don't have, is it?
I saw the map. They wrote there Gomba, right?
Yeah.
I don't
That's
know
what my
where
husband
the
said.
train is there.
Gomba,
So
the
from
one-
Gomba, sorry. That's why I was telling you. From Gomba, you can go to Kuantan, to Kelantan also. That one, I think the train travels around 180 kilometers.
How long does it take from here to Kelantan?
Before that, I think.
Yeah. No, to Kelantan, I think 5 hours. 2 hours.
2 hours to Kelantan. I think not quite
2
close.
hours.
From not, I mean from the gate.
From Gomba to Kuantan, it's 2 hours. Okay lah.
Fast lah,
Fast,
quite
it's
good,
quite
right?
fast.
Yeah.
It will go good for the Malays also lah. Raya time when they travel now, you're stuck in the jam Karawang highway after that.
But 2 more years, is it?
Yeah. But it's good we have more railways for us. Okay, this is monorail. As you can see, it's got a rubber wheel. Okay, this is standard. That is EMU, and that one is LRT. Okay. This type of trains. Okay. And now what we have here is our Raj expertise lah. Okay. It's the power supply. Okay, we have stations, rectifier substations and all that. Okay, from this substation is where the supply is laid to the track. Okay, via cables, and then from cable it goes to the rail. Okay, and all this is monitored by the SCADA system. Okay, and all the supplies and it's controlled remotely by the controllers, by the power controllers. Okay, we also have technicians who have to go at site and to do switching, manual switching with the breakers and all that, and sometimes intervention when there's faulty and all that. Okay, so just now we have track. Okay, we already have the infrastructure, we have the track, okay, and then we have the power supply, we have all the lays, this one cable all laid, and we have the train. Can we run the train, railway? You have all the four major things already. Can we? Can I? How you want to go to the station? Okay, this is before going to that. This is how the supply is given to the train through the cable. Okay, this is called pantograph. Pento. It's air driven, so it can come down. Well, once it come down, there is no supply. So once it's come up, it will touch the rail. Okay, this is another way of getting the supply. It's called third rail. Okay, there's a shoe. There will be a shoe at the train which touches the third rail, and once it touches, it gains the power 750. Okay, from that power, that is where the train is moved by using the traction motor and all that. Okay? And this one is AC. This one is DC. Ini kena tendang, ini kena tarik. Okay, which is dangerous. If you can see here, this is much more dangerous because you are walking along the track. Okay, and what happened when I told you they get electrocuted is normally there's walking part and all that. Some Superman and all that, they put the leg inside, in between.
Oh.
That is what happened.
She one of my cousin also
and
died.
imagine, sorry, what is that?
One of my cousin also died due to this. But he was
KTM.
not. KTM. It was in
KTM
Johor.
cable
No, was it KTM? I don't exactly know, but I know that it is because of the track. But he's a bit like off his head lah. He has some mental health issues. So one of the days he was like, in the morning apparently he just walked around the track, and then one of the train.
I think that one must be
Different.
KTM.
Oh, KTM.
Not electrocuted.
Oh.
That one hit. Got hit. This one is electrocuted. You get stuck there.
So it will be different. It will be like you get burnt, is it?
No,
what
you
will
hit,
happen?
normal hit is like a car accident.
Train accident.
Okay, that one is hit by train. This one?
This one is electrocuted.
So you.
When you walk along this.
Oh, when you walk along this.
And this is energized, 750 DC.
Oh. What will happen to the
You
person?
should not
Die.
Die as in
Barbecue.
they will like normal. They will be
Barbecue.
yeah, they will like get
just
burnt,
all
right?
the skin will
Yeah.
come off. Okay, that's some degree of burn or something.
Has it happened in Malaysia?
Yeah. Pudu, we had one case in Pudu, 2-3 cases, even one case of staff.
Oh.
Staff was the same. Okay, he didn't follow the rule and all that. He didn't report to the control saying that he's going down.
If they are stuck there, that's it lah.
That's
There
it.
is no way of saving
And
them.
normally when people get electrocuted here, the power supply will trip.
Oh,
Okay.
it's
But-
like auto response, is it?
No, it's called what is tripping lah? Ground. Ground.
Oh.
Okay.
Error, I'm not showing for error something.
Something like
No, you get ground. The cable get grounded. It get connected. Let's say I put a cable from here to here. This is live. This is neutral. When I put it, then the breaker will trip. Same goes for
Short circuit.
depend short circuit. But depend if it's a small size or sometime the amount of M is not sufficient, so it doesn't get tripped. People don't know.
Oh.
Like cat, dogs,
only
we don't get doesn't get tripped. Okay? So depends on the flow of the supply whether you can get tripped or not. Yeah. So for the manual thing, I have one experience lah. When we were doing KTM commissioning, that means from loco is an engine where it makes noise and all that, and it moves slow. Okay, loco moves very slow. So our people are used to this loco thing, and then all the trains were at grade. Last time we didn't have jambatan all, no viaduct or anything. All the train was traveling in the at grade. Okay, so when we first had our KTM bought commuter, the first electric train, when we started doing commissioning, okay, because commuter can go up to 120 kilometers. commissioning is we buy the train, we test. Okay. So these trespassers was so used to looking at this locomotive, they were so confident lah. When we were doing our testing, they were walking, they see the spotlight. Normally, for engines, you see the spotlight, it's very bright at a dark area. It's very bright because it's moving slow. You still see the lights, When you take a commuter, they still see the same headlight, very bright. But what they don't know is that train is traveling faster. So when they see the light, they are so confident, they just walk. The train is near already. I myself have killed 7 people when we were doing the commissioning. We got phobia already, don't know. Within 2 months, I hit 7 people. Not only me, whoever who were doing the commissioning. Then we stopped. Then we then came out in the newspaper advising people. They put back the fence.
They actually cross just like that. So that is when they get hit, is it?
Because they are so confident, and electric train got no sound. They don't see that. Okay, we are fast. You remember I told you the maglev, when I was there, we call it train crossing, different bond when they cross. It's like split second only, I see a train coming, I see a small light, poof, Eli.
Oh.
Imagine how fast is that. Okay? So the same thing happened in KTM had this problem.
Mr. Ravi, just want to ask you a question. So when these things happen, right, is it traumatizing for someone who operates the train?
Yeah.
How would you?
My first case, I got I had the phobia. Normally they will put us to office hour, grounded for a while. Okay?
But
So
that's not
depend
your
on the
fault,
cases.
isn't it? It's because
It's
they
not
are
my
actually
fault,
trespassing.
but it was like that when we hit someone. Let's say I hit someone in Slim River. The driver has to go to Slim River, make a police report. If the family charge, okay, they will charge, they will charge. Okay, when they charge, we have to go to the court. But
So
of course we
happened
will
here
win lah.
Mm.
Okay, sometimes we don't know, these people, they will charge, they will make a police report, they say driver to the tower, but they are trespassing.
Yeah, trespassing. Yeah.
Because this was when the interim process from the locomotive where we changed to electric trains when they didn't have sufficient fence.
So we just want to check this. EMU all don't have horn or emergency
we have.
brake, so unable
They
to
have
on them.
every trains, but EMU that is compulsory. Horn is a compulsory equipment. We call it critical fault. If the horn is not working, they don't take out the train.
So let's say like emergency stop, right? Emergency stop of a train. So when will it happen? Like
You mean for EMU?
Any train, any cases like
EMU is different. EMU emergency stop is they apply the brake, and then now EMU is fitted with the signalling system, where when the train driver drives exceed the limit, it will trigger the train alarm system and emergency brake will apply. Okay. As for automatic, of course, it is all auto. So we don't for automatic we don't have the train going speed by himself lah. We don't have AI doing that. I give a command and the first say no, I want to go more. We don't have that problem. For manual, yes, we have that problem because some drivers, okay, the speed restriction is 50, the fellow will try to go until 70, but the moment he goes above 2 kilometers, there will be a buzzer, and then he goes above that, within a second, the brake will apply by itself. You don't listen, we stop, and then it's recorded.
So we'll have penalty and everything.
Depend.
speed trap someone.
Yeah, it's called a speed trap.
Uh-huh.
Okay, it's called a speed trap. Okay, and yet we had some drivers who bypassed that safety thing and proceeded, and the train derailed.
Oh.
So derailment happen when it's overspeed usually.
It depends. Mainly, a lot of derailment have occurred because of overspeeding,
Overspeed.
human error.
Mm.
Overspeeding.
So it's like the accident we had some time back, is it?
Yeah. Which one?
The one, where was it?
Klanajaya.
Yeah.
That one is signaling
Oh,
human
different.
error.
Oh, human.
That's not overspeeding.
Not
That is,
overspeeding.
he didn't get the authorization and just moved the train. Okay. Now, as we were talking, we actually went to signaling topic already. Okay, signaling. This to install the signaling. Okay, you can see we have two kind. We have wayside signaling, which is fitted along the track, and then we have signal beside the track. Now we are using Wi-Fi and all that. Okay. And then we have signals also transmitting to the control center in two ways. One is fiber optic cables and also frequencies. We have 2 or 3 modes of getting the signals. For some they also have GPS. Okay. So these kind of signals, the main reason why we have all these signals, one is if it is manual, you see the manual thing, okay, it is to check whether there is a train ahead or not. When there is no train, we get green, we proceed. If it is red and you still proceed, then the signaling will trigger the train system for emergency brake to apply. It's like that. Okay, and whatever we have in our car is what we already had in the railways. It is all from the railways which was taken and implemented in the cars. The development of cars all started from the signaling system of what we had in the railways. So the railway is the father, okay, like our traffic lights and all that. Okay, before anything existed, train already had all these traffic lights. Okay, you can see those days, I don't know whether you remember, we call it semaphore arms, even wood type of signal, and then color lights. Okay, color lights is the traffic light what we have at the moment. Okay, so all that technology was taken and applied to our road and also inside our cars. Okay, like when we open the door, it shows that the door is open, the door indicator, we call it the panel. All this was in the railways years before. All this was there. From that they took the technology. Even now, when we have in future, when we have the manual or automatic parking, automatic driving, it's all taken from the technology of the trains. Yeah? And speeding also. Yeah? I don't know, we don't have at the moment, but we can cruise, right? We can set cruise for our cars and all that. But certain cars we also have anti-skid and all that. So all these, the signaling system is all taken from the trains. Yeah? In train, we have the wheel, right? If the wheel moves a bit different, there will be alarm for us, showing that this thing is happening in the train. Call it wheel slip. Yeah? So this is the type of equipment normally we have at the track sites. Yeah? This is how it works. Yeah? So we have, this thing is copper and it's very expensive. So we have some specialists who go down to the track and steal that cable.
Oh.
Okay?
Okay. They dare to do it, huh?
Yeah, some get electrocuted. That's why I told you there are some cases attenuated, but now they are much more smart. They know that there is maintenance work going on at that place. I don't know how they get to know that.
Inside information.
And then at that point they know that the power is de-energized. So at that moment, within the 2 hours, they will go down. Sapu the cable. This cable is not cheap, It's not cheap. It's very expensive. Yeah, pure copper.
Oh.
And they even have rope, There's one case last month. They actually had a rope. They climbed up to the viaduct and went and sleep.
Wow.
Once they detected there's a thrust power, they just jump and run. So the rope was hanging. So imagine how they did. Okay, this is a type of signaling system which is fitted along the track. This is for manual train operation. Okay, so if there is a train in front, there's a train in front, it is called red, green light. Red, green, red. Okay, you understand? Okay, that means if there is a train here, okay, it will always show there is no train behind, right, in front, right. So it's clear for this train to proceed. Once this train goes here, okay, the rear signal will become red. It will stop. Another train to go inside. Okay, and here what we practice is whenever there is one train at the section, 2 signals behind will be red. We call it buffer system. Okay, buffer. It always has a buffer. That means when the train is traveling, okay, so red, green. Okay, when the train is here, it's always red here. When the train clears this one will be green. It's always a section. Okay. It's fail safe. We had one incident in Bukit Jalil where this thing failed. Okay, that thing failed. So normally when it fails, you have to use radio to get authorization from the controllers to proceed. What the controller will page for the head train, asking him for the location. So the location is clear, then he will authorize the rear train to proceed with a default mode. That means he will isolate the protection system. So once he isolates the protection system, the train speed will automatically reduce to 40, because they don't know the difference if there is any obstruction or what. So at that point of time, the signal didn't work. Default, we had a fault, signal fault. The radio at that area, we had a blind spot where the radio was not working. They are supposed to put a repeater, but they didn't put. So that also they didn't do. And then what happened was they employed someone from automatic system to come here as a boss, and he found that because the signal is red and no communication, so it is very delayed at that section where it jams up, trains start to pile up, and all train will come and stop, get authorization to proceed. When they proceed, the rear trains are waiting, especially at the peak hours. So he gave an instruction, train to proceed normal speed at that area. Okay, which it should not do lah. So what happened is no radio communication, and then signaling is not working. So one driver, he tried to call the control, he couldn't get, so he was like overconfident. He just passed the signal and proceeded normal speed. There another train failed here. One train had failed. He cannot use the radio. because radio is not working, so he could, at that area has got blind spots and all, so he couldn't contact the control center. So this train went and hit Lanka. Okay. There was this system defect for nearly 4 to 5 months, 6 months actually. Okay. Immediately when the accident occurred, the next day they replaced it.
Oh.
They put a repeater, additional repeater, and for the radio, additional signaling detection system, all can be done. Okay. Immediately.
Because
So
of the
that is the importance of signaling. Yeah. No doubt, railway is safe 99.9999%, but in case of any accident, it's all iron. Tukali Langga Jalan. You can go to YouTube and check the train accidents and all that. Okay, once it happens, it's like a major disaster. Yeah. Okay, these are the types of signaling. Okay, now we come to another thing which we will talk is the access. Since we all are using closed system, the access to the train is via the stations. You cannot access by entering in the middle of the section or anything. You cannot cut the cable and fence and go inside and board a train. You cannot do that. Okay, so we are using closed systems. Closed systems is where we have stations. We have many kinds of stations nowadays. Okay, Changi station. Okay, you see now it all looks like Starship. Okay, port and all that. Yeah, and another thing about closed system is we get the exact figure of the ridership. Each time a passenger goes in, it's recorded, and a passenger exit, it's recorded. Okay, so we know what is our ridership for us to do the statistic and all that. So it's very easy to track, knowing all this. You come in, you go out, we know. Okay, last time KTM and LRT, they had stations. When you buy a ticket, let's say from Ampang to Pandaninda, which is 4 station, you buy a ticket only for that 4 station. Okay, when you purchase a ticket, once you exit you go to another station. Okay, when you exit, you cannot exit, you have to pay extra charge. Travel destination. Okay, initially now no. Now it's and then we also had 2 hours. You can only be in the system for 2 hours. When you are above 2 hours, you have to pay penalty. This is why, is because last time when we first implemented all the trains, people were so excited. They start loitering inside the station, lepak there and all that. But now no. Now it's you can travel anywhere you want. But still the same of the travel destination. Okay, this is all tracked from the station. Okay, so in station we also have people who can man and operate. Some of them can operate the trains and all that. Okay, now as I told you that to check all the destination, your calculation, our revenue is all, we call it as AFC system. Okay, now you have the track, you have the infrastructure, you have the track, you have the building, you have the train, you have the station. Okay, you want to run the operation, you need to make money, automatic fare collection. Okay, we call it as AFC. Okay, so we also have ticket vending machines where you can issue a card, okay, or a token. Okay, this is all for the closed system where you enter the track, enter the train from the gate using the gates, okay, and exit using the gates. You see, all this you can see in the airport nowadays, right? And a lot of places. This design is actually 20, 30 years ago. That's why I tell you a lot of things was used in the railway. Not because I'm in the railway, I'm bragging about railway. But it's a fact. Okay? And then additional to that is passenger information displays. Okay, last time, yeah, we used to have all kind of these written things. Even you can see that in the KTM now, they still have that. All the timetable of which train going where. You see Malacca, they have Malacca 18 40 cents and what time it's departing and all that. Okay, and now we have a bit Changi lah. Oh, I don't have the picture of that. Now it's all electronic displays. Everything is electronic. Okay, so our passenger display system, this is text type, and then we also have audio PA system, which we will announce if there's a delay or normal frequency of the trains, in case of emergencies. Everything will be announced, and if we fail to announce, the passengers will report to MOT saying that they don't hear any announcement or they cannot see any displays at the stations. And also in the trains we have DRMD, digital route mapping, which will show you where is the train and what is the next stop and when it's going to stop and all that. So we have all these two. Yeah. Okay. For PA system, we also have a lot of type of telecommunication things which is fitted in the train and in the control center. Okay, if we don't have this telecommunication, we cannot run the control center. I mean, this is mainly for not even manual, even for remote, both. This is one of the essential equipment. Okay, it's like a vital equipment for us. Yeah, nadi. Okay, signal danger. Okay, now I think all of you know now how it is operated. When we have the train and everything, yeah, before we start, what we do is we plan. How we plan is we have the planning department. This planning department is where they plan to see the ridership. Okay, that is why we have peak hours and off-peak hours. Okay, for peak hours we have more trains. Okay, when we have more trains, the frequency of a train, that means a train comes and stops at the station, and the next train, which is called frequency of the train, is lesser. More trains, less frequency. Less train, more frequency. That means less train, you wait longer. You miss a train, you have to wait for the next train nearly 10 minutes like that. Okay, more trains, okay, is where you have less. That means you miss a train, you make for another 4 minutes. Okay, what frequencies which we have at the moment in MRT and LRT for peak hours at Ampang line is 2.6 minutes. That means you miss a train at peak hours, you wait for another train within 2 minutes. For MRT, it's 4 minutes. For KTM, I'm thinking, and I'm thinking. I'm not sure. Okay, I think the frequency is 10 minutes, I think. Okay, one of the reason KTM cannot achieve less frequency because of the signaling system. Remember I showed you the red, green? It works like that. But for automatic trains, it can go near. It can go very near. So always there's a difference and there's a gap. Yeah. Okay, this is how it is operated. So we have our planning department who will plan. Okay, what they do, they will do a survey, ask people and ask how it's going to be done and all that. Okay, and then we manage. So this peak hour is not only about providing the trains, it's also providing the staffs. You need to have the sufficient staff at